and welcome back to this amazing channel. In this particular video, we will discuss about weekly contest 405 of Leetcode, and we'll discuss all the 4 questions of this particular contest. I will say that this contest was not that much difficult. Even the first 3 problems I will say were of good, not like of basic level only. And then last problem was a problem of, I will say, try plus DP, which was a little complex problem, but yeah, not very complex as we are seeing from the last some contest. So let's discuss all the problems one by one. We have 4 problems of this contest. This is weekly contest 405. Okay, amazing. So the very first problem is find the encrypted string. So what this problem says, according to this problem, they are saying that you are having a string s and an integer k. Now you have to replace every character of C with the kth character after C in the cyclic manner. Okay. So basically, let me explain you what they are saying. For example, in your test case, let's say this is your S and this is your K. Okay. So I will say this is your S, okay, which is Dart. If I will index it, it is 0, 1, 2, 3. Now what you have to do, from this string S, you have to replace all its character with kth character after it. So for example, for this zeroth character, it will be replaced with 0 plus 3, means the third index character, which is T. Now this first character will be replaced with 1 plus K, which is fourth, and you can see the size is also 4. There is no fourth index, so we will take mod of 4. So it will be replaced with 0, which is D. Then R will be replaced with A, and then K will be R. So it will be TDAR, right? And that is what we are doing. So first of all, because we have to make changes in the string, I'm first storing this original string in another string called SS, and then I'm making the change in the original string only. How I'm making the change? First, I took k is equal to k mod n, because obviously the value, if the value of k is very large, we don't need it, right? We don't need the value of k as very large. Okay. Next, what we will do is, next for every I, with which index we have to replace? We have to replace with I plus k, and that I plus k also in the cyclic manner. So we are taking mod k, and then we are replacing the value of si with ss of j, with the original string j, right? And then we are returning it. This is a basic problem what we are doing. If we talk about the time and space complexity, time complexity of this problem is order of n, and space complexity is constant order of 1 only, right? So this is what the first problem is, a very easy one. Okay, cool. Let's move to the next problem, guys. So next problem is generate binary strings without adjacent 0. This is also a very basic problem of recursion, even not DP, because you will see the constants of it. We can just use simple recursion 2 to the power n to solve this problem. How? So basically this problem says that you have to generate all the binary strings without any adjacent 0. So in a binary string, there should not be any adjacent 0. कोई adjacent 0 नहीं होना चाहिए. How we can find this string? So we'll simply check for all recursive case. Okay. So for example, initially our string is empty. Okay. So from which number we should start it? So we can either start it from 0, either start it from 1. Now from this 0, 1, after that also there will be recursion calls. But the thing is that we should not have adjacent zeros. Basic यही agenda है. ठीक है. So basically they are saying if we will take any substring of length 2, it should contain at least 1. तो means basic क्या है कि कोई भी adjacent zero नहीं होना चाहिए. ये आपको करना है, right? Because they are saying that a valid substring is valid if all the substrings of x contains at least 1 1. So if there is at least 1 1, that means there should not be continuous 2 or 3 zeros, right? 1 होना ही चाहिए हर थोड़ी दूर पे after every second index. So basic thing is you have to generate binary strings without adjacent 0. So basically, let's say if the start of the substring is 0 or 1, after 0 we cannot have another 0. It should not be like 0 0. So when the last character is 0, next character will be 1 only. But if the last character is 1, next character we can take 1 0 also and 1 1 also. Now again, from here it will be two recursion call, 1 0 1 or 0 1 1. From here it will be just single 1 0 1. From here it will be 1 1 0 or 1 1 1. So this is how, guys, all the recursion call will go until we get the number of characters what we want. Let's say we want size 3 only. So these are the 5 strings which are possible. You can see. So how we are doing it? So I'm creating a function called generate string, what this function is taking, this function is taking int n, means the number of characters remaining, as is the current string of that recursive call, and int is the last character that we have taken. So if the last character we have taken is 1, means now in this recursion call I can take 0 also and I can take 1 also. If previous was 1, now I can take 0 and 1 both, because there is no adjacent zeros happening. But if the last character was 0, here I am saying if the last character was 0, then this character we should take 1 only, we should not take 0 again. Okay, and we will call this function starting from 0 and starting from 1 from both the sides. Okay, so that's the basic thing. And then whenever n becomes 0, means we have got all the characters, I'm inserting my string inside the answer. So it is just a recursive function, a basic recursive function, not no complexity. If we talk about a time complexity of this problem, it is order of 2 to the power n, and space complexity, as such there is no space complexity, but if you will see the recursive stack, then there will be. Otherwise we have just taken the space for storing the answer, which we don't consider, so it will be constant only if we ignore the recursive space, right? So this is how we are solving this particular problem. I hope that it makes sense, right? Amazing. Now moving forward to the next problem, which is count submatrices with equal frequency of x and y. See, if they are saying us that we have to find all the submatrices of equal frequency, then it becomes little complex. But they have actually added one more condition which makes this question very easy. Let me first give you an example. Example hai, let's say first create a matrix. So let me first create a matrix of some size, and using that matrix I will explain you that how to solve this problem. So let's create a better matrix. Let's create a better matrix. Okay, and now this matrix will contain three things. Either the cell is empty, means there's a dot, either it contains a x, or either it contains a y. तो ये तीन चीजें हो सकती हैं. तो for example, let's say there's a x, there's a dot, x, y dot. Then there is a x, then there's a, let's say, a dot, then y, then x, then y, dot, x, y, x, dot, y, x, y, x, y, x, dot. I'm placing very random. Okay, this is the matrix, let's say. Okay, if you will see the size of this matrix, so the number of rows are 6 and number of columns are 7. Okay, this is the size of the matrix. Now next what we will do, next what we should do, see, we have to find a submatrix which should contain equal number of x. That is what the question says. So if you will see, if you will see, this can also be a submatrix. If you will see, ये भी एक submatrix हो सकती है जहाँ पे equal number of x and y है. This can also be a submatrix with equal number of x and y. Okay, this can also be a submatrix with equal number of x and y. This can also be, but the thing is, they are not just saying like this, because they are saying that the submatrix that we have to find, number of submatrix that we have to find, it should contain equal frequency of x and y. That is fine, and there should be at least one x. That is also fine. कि at least एक x होना चाहिए, दोनों सेम होना चाहिए x और y की फ्रीक्वेंसी. बट उस सब मैट्रिक्स में ये जरूर होना चाहिए, that सब मैट्रिक्स should contain, that सब मैट्रिक्स should contain the 0,0 index. मतलब जो सब मैट्रिक्स है that should start from this particular cell. So it can be this, it can be like 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 this, but basically if there's a some matrix like this, तो उसका जो ये वाला कॉर्नर है, means its top left corner, this should be grid of 0 0 only, means this should always be taken, right? if somehow we can get number of x and y in every submatrix starting from here, we'll get the answer. And for that, guys, we will use the technique of prefix sum. Let me tell you how it is, okay, how it works actually. So what I will do, I will make this little smaller. Can we? So we cannot, I think. Oh, this is not a good thing. I thought कि the size can be managed, but no. It will be very difficult then. तो एक काम करते हैं, थोड़ा सा smaller matrix ले लेते हैं, ठीक है? एक काम करते हैं. Let's take a smaller matrix. This is very lengthy. हो जाएगा, हाँ. यहाँ से भी 4 हटा देते हैं, ठीक है? Okay. And now we will create a. What I will do, I have to know कि till a particular cell starting from 0,0 to let's say x, y. यहाँ से यहाँ तक की जो मैट्रिक्स बन रही है उसमें कितने x हैं कितने y हैं. How many number of x are present, how many number of y are present. Let's say that we are considering this much part. So we should know that, or let's say this much part. So we should know that in this part of the matrix there are 4x and 3y. That means it is not a valid matrix. It is not a valid submatrix because number of x and number of y should be equal. But at the same case, if you will take this or if you will take this, you can see that here it contains 2x and 2y, means it is a valid matrix. So for every x and y, we can check starting from 0,0 till that x, y, is there a valid matrix or not. But the problem is how to get that number of x and number of y, because if you will solve it, in a brute force manner, it will give TLE, right? So for that, guys, there's a method of prefix sum. Just like we can find prefix sum in a 1D matrix, we can also get the prefix sum in this 2D matrix. How? So for example, this is a matrix. I will create a copy of that. Okay. And in this, what I will do, initially all the cells will be empty. So what I will do, I will make all the cells empty. And this cells of this 2D matrix is actually a pair of two numbers, where first number will contain number of x up to that cell starting from 0,0. And second value contains the number of y starting from 0,0. तो मैं क्या बोल रहा हूँ कि जो मैट्रिक्स है, this matrix will actually contain pairs. It will contain pair, and that pair first element will tell number of x from 0,0 till that index, and y will tell number of y. Second will tell number of y, right? Initially, I will make the whole matrix as 0,0, 0,0. तो पूरे में हम लोग 0,0 ही कर देंगे initially. Okay, initially we don't know. If you guys know how to find the prefix sum in 2D matrix, you can check out that. But I will tell you how to do that. कैसे करेंगे हम लोग? तो उसके लिए हम क्या करेंगे कि we will actually first take for the first column. For the first column, you can see for every row, value will be whatever is there. तो आप देखो कि यहाँ पर एक x है, ठीक है? So the value of this will become 1. Means at this particular cell there is 1x and 0y. अब देखो एक x है 0y. This will be 0, 0, 0, 0, no change. Here it's a y, so it will also become 0, 1. 0, 1 means because y है, 1, 0 because x है. Now moving forward, हम सबके लिए निकालेंगे, but while we will find for others, we will also take the prefix sum. जैसे कि आप देखो यहाँ पर कुछ भी नहीं है, there is a dot, तो it will be also 1, 1. प्रीवियस वाला आ गया. सिमिलरली यहाँ भी डॉट है, इट विल बी ऑल्सो 1, 1. इसका पीछे वाला आ गया. यहाँ एक और x आ गया, 1 more x कम. प्रीवियस तक एक x था, अब यहाँ एक और. अब देखो इतने में 2 x आ गए, तो हम क्या करेंगे 2, 0. यहाँ पर आप देखो प्रीवियस तक देयर आर 2x, नाउ 1 y के, तो नाउ सेकेंड विल इंक्रीज, सो इट विल बी 2, 1. तो अब देखो इसका सम क्या, अगर हम बात करें इस सेल, तो ये सेल क्या स्टोर करें, ये सेल स्टोर करें 2, 1. वाई 2, 1 बिकॉज अब देखो कि इतना जो सब एरे है उसमें 2x है, 1 y है. एंड दिस इज हाउ विल फाइंड फॉर एवरी रो. तो अब हम एक काम करते हैं, ये इनिशियली 0 रहेगा, मैं सबको इरेज कर लेता हूँ सो दैट हम बेटर वे में उसको कर पाए। तो पहला रो तो हमने बना ही दिया है, ठीक है। फर्स्ट रो वी हैव ऑलरेडी क्रिएटेड, नाउ वी हैव टू क्रिएट फॉर अदर रोज। आफ्टर द फर्स्ट रो वी हैव टू क्रिएट फॉर अदर रोज, क्योंकि फर्स्ट रो की फर्स्ट रो कह रहा हूँ, फर्स्ट कॉलम विल बी जस्ट इफ x इज देयर मेक 1,0, इफ y इज देयर मेक 0,1। अब नाउ इसके देखो, यहाँ तक इट वाज 0,0, नाउ वन y केम सो इट विल बी 0,1। now it here it will be 1,1, 1x 1y, okay। now it will be 1,2 because 2y came, and then again 1,2 last dot है, ठीक है। similarly यहाँ पे 0,0 again it's a dot, then it will be 0,1 a y, फिर 1,1 a x also, and then again 1,1, here it will be 1,1 फिर 1,1 1,1 1,1, ठीक है। this is how for every row you say, still it's not a matrix, still if you will see what is this 1,1, this 1,1 says that in this row till that index there are 1y and 1x, but we have to find for the matrix now. Let's say if we are saying for this cell, it should tell for the whole matrix till this cell started from 0,0. For that, so currently we did prefix sum in the column like row wise. Now we'll do this vertically. How? Like this. So now vertically आप prefix sum निकालो, तो it was 1,0, okay, now it will also become 1,0, ऊपर का sum कर लिया, this will also become 1,0, and then this will become 1,1 because already there is also 1,1. Now see, this was 1,0, add with it, it will also become 1,1. now this is again 1,1. now this is 2,2 because that 1,1 is added. now this will become 2,1, ऊपर का 2,1, हाँ। now this will become 2,2, this will become 3,2, 3,3. now this will become 3,2, no, पहले क्या था, हाँ, it will be 3,2, then it will be 4,3 and then 5,4, so 4,3 5,4, okay। now this will be 3,3 and this whole will be same 4,4 5,5, okay। अब if you will see, now this contains number of x and y starting from 0,0 till that particular cell. Let me give you an example. Let's pick this cell. This cell is 1,3. Get it from here, 1,3. It is saying 3,2 means 3x and 2y. You can see in this cell there are 3x and 2y, right? Similarly, let's check for this. Let's check for, let's say this much part means this index. This index says 3,3 means there are 3x and 3y starting from 0,0 till that particular cell. So now this matrix can tell us that starting from 0,0 means for that particular submatrix, what is the number of x and y. And finally, we have to find some matrix having equal number of x and y and at least 1x. So we will find that cells. So आप देखोगे यहाँ पर कि this is a cell having equal number of x and y. This is also there. This is also there. This is also there. This, then this. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 will be the answer. The number of submatrix having equal number of x and y. Okay, and you can see I have done the same. So what I did, I first have created a 2D matrix of same size of pair as I told you, which is initially 0,0. Then for the first column, initially I will, if there is a x, I will make 1,0. If there is a y, I will make 0,1. What we did initially here. यहाँ पे हमने यही किया था ना. Then first we will find the, like I will say, row wise prefix sum, right? This is the row wise prefix sum we are finding first. Okay, where if there is a x, what we are doing? From the previous prefix of I comma j plus 1, prefix of I comma j second base. So देखो, prefix of I comma j I made equal to prefix of I comma j minus 1. तो जो अगली वैल्यू थी हमने पिछले वाले इक्वल कर दी. अब इंक्रीज कब करेंगे? If there is a x, increase the first. If there is a y, increase the second. This is the row wise prefix sum. Now column wise prefix sum. Now for column wise prefix sum क्या नहीं करना, कुछ नहीं करना है, बस when we are going down, इस वाले में लास्ट वैल्यू बी एडेड, देन सो एवरी एलिमेंट में हम उसकी लास्ट वैल्यू को ऐड कर देंगे. तो अब देखो आई एम एडिंग प्रीफिक्स ऑफ आई कॉमा जे फर्स्ट में हम लोग प्रीफिक्स ऑफ आई माइनस जे फर्स्ट ऐड कर रहे हैं. सिमिलरली प्रीफिक्स ऑफ आई कॉमा जे सेकंड में प्रीफिक्स ऑफ आई कॉमा जे जे माइनस आई माइनस वन जे को ऐड कर रहे हैं. तो फाइनली वी हैव द प्रीफिक्स एंड देन एट द लास्ट जो ये फाइनल मैट्रिक्स हमारे पास में, इन दिस फाइनल मैट्रिक्स वी आर सीइंग दैट फॉर विच सेल the number of first and second means the number of x and y are equal, and also there is at least one x. If this is possible, make answer plus plus and then simply return that answer. So guys, this is how we are solving this particular problem, and I think this is a good way to solve it. If you talk about the time complexity and space complexity, time complexity for this is order of n into m, and space complexity is also order of n into m because we have taken this extra prefix sum wala vector of pairs, and space is time is obviously n of m. We have nested loops, right? Cool. So this is how we can solve this third problem, guys, called count submatrices with equal frequency of x and y. Now finally we have this question of it is a question, guys, of try, because here also you can see this something some prefix strings are coming. So it's a question of purely try. With dynamic programming also, because you have to find the minimum cost, so dynamic programming करनी होगी. So I have actually tried to solve this one before without using try also. I just tried that whether it is possible or not, but yeah, it was running up to 712 test cases, means the logic was right, but yeah, it was not having right time complexity because map takes a lot of time. Okay, so I will tell you both of them ki how they both are working. Okay, so basic question is that we are having a target world and we are having some worlds and the cost of the world. So we have to make this target world with the help of this given words, and we have to find the minimum cost for making it. ठीक है, तो देखो पहला तो हम क्या करेंगे, we will have a recursive solution which I actually tried. So if I will take the same test case, so if I will have the same test case, let me just add it, right? And also guys, one more thing is there, that for the same character one can have different cost also. For example, let's say मैं इसको थोड़ा change करता हूँ. Let's say here is a ABCD. Let's say there is one more ABCD, and the second ABCD is of let's say cost 200. So which ABCD will you consider? The cost of first ABC is 1, second is 200. So you will obviously take the smaller one. तो मैं क्या कर रहा हूँ initially I am storing all the value in a map with its cost, with its minimum cost. मतलब देखो मैंने कहा भाई जो ABCDEF है it is of 100, then जो ABC है it is of 1, then D is of 1, then DEF of 10, then EF of 5, and then again there is a ABC of 200, but we will not take it because we will take the minimum. तो हम क्या करेंगे, हम हमारा मैप लेंगे. If you will see this question which is giving TLE, I'm first explaining you that, okay, कि how with TLE we can do at least. तो हम क्या कर रहे हैं, initially I'm taking a unordered map, and in this unordered map for every word I'm storing its cost, and if for a word cost is already present, I'm saying take the minimum cost. Okay, then I have a recursive function. What this recursive function is doing, so this recursive function will actually start from the index 0 only. It will start from the index 0. मान लो हमारा वर्ड है ABCDE, तो we will start our indexing like 0 1 2 3 4, and our recursive function will start from the index number 0. Now from this index 0 it will see for which part of the string it is present in the map, and we should take it. For example, ये A है, क्या A इसमें present है? नहीं. Then there is a AB. AB is present? No. Then there is a ABC. Is ABC present? Yes. ABC is present with the cost 1. So there will be one recursion call with cost 1 and with the remaining string DEF. Now there will be one more recursion call for this much part. You can see ADEF 100. Whole string is there. So it will be 100 only. Now for this much call, there will be again a recursion call. So for D, separate call is there, which is again D cost 1. So it will be 1 plus 1 2 plus EF के लिए separate. या फिर total DEF is also present. Total DEF is for 10. So total cost will be 11. 1 plus 10, 11. Now for this EF, it is present with 5, which is 7. तो यहाँ से 7 आया, यहाँ से 11 आया, यहाँ से 100 आया. So minimum of them will be 7, which is the answer. You can see for this test case, answer is 7, right? But guys, but this DP I will not explain much because this DP will give you TLE. We are using map, ठीक है? ये आपको TLE देगा. You can see in the very last test case में दे रहा है, मतलब ऐसा नहीं कि logic is fine, but it is giving just TLE. Okay. Now how we can solve it efficiently? Obviously, we will use try for it. So in the try, for every string, we will insert it in the try, and then from the try, we will also store the cost we are taking to create that. Okay. तो हम क्या करेंगे कि initially, let's say we have the root of this try, okay, and we have all these so we have all these string with us. Let me take this here. Some problem happened. This after a update from of this open board recently, it is lagging a lot. That whole text is gone. There is some problem. Okay, let's take our words from our side. So this is a root. Okay, and let's say that we are having some words. Let's say our target is that A, B, C, D, E, F only. Okay, and words is, let's say there is a word ABC with cost 100. Then there's a word BC with cost 50. There's a word, let's say D with cost 10. There's a word DEF with cost 70. There's a word EF with cost 50. And let's say each word can also have multiple costs. Let's say D also has a cost of 50. Then EF has also a cost of 20, and so on. Okay. So we will take the minimum cost. So now for this, and our target string is A, B, C, D, F. Okay. So first of all these strings of our word, we will insert in the root. So first there is a A. So A will come, then B, then C. And the cost will be 100 here. Means to make from A, B, C, it is 100. Then there is a BC came, so it will be a B, then a C with a cost of 50. I hope that you guys know try. So if you guys don't have the understanding of try, for that I will recommend to please watch a video of try, and then you can check this problem. Okay. Then there's a D of 10. Then there's a DEF of 70. Then there's a EF of 50. Then there's a D of 50, but already we have a D of 10, which is better. So we will take the minimum cost only. Then there's a EF of 20. So previously it was 70. Now I will make it 20. So this is how first of all we will create our try. If you will see how it is created. So this is the basic class of try of 26 children from A to Z we have taken. Initially all the children is making null pointer, and initially the cost of every children, means the value which every children is taking, cost, is int max. तो हर चिल्ड्रन के पास कोई कॉस्ट होगी कि भाई टू मेक टिल देयर व्हाट इज द कॉस्ट, एंड इनिशियली आई विल मेक एवरीथिंग एज इंट मैक्स बिकॉज वी डोंट नो दैट वेदर दैट स्ट्रिंग इज प्रेजेंट और नॉट, राइट. अब हम क्या करेंगे, वी विल सी हाउ वी कैन इंसर्ट फंक्शन इन ट्राई. तो इंसर्ट करने के लिए क्या फंक्शन होगा, सिंपल है, जस्ट लाइक वी इंसर्ट इन अ सिंपल ट्राई. इफ यू नो, वी विल सर्च फॉर द कैरेक्टर्स इन द वर्ड. लेट्स से अब ये हमारा ट्री है, इसमें लेट्स से हमें इंसर्ट करना है बी डी. तो आई विल सर्च फॉर, फर्स्ट सर्च फॉर बी. क्या बी प्रेजेंट है? यस, बी इज प्रेजेंट. नाउ आई विल सर्च फॉर डी. क्या डी प्रेजेंट है? नो, डी इज नॉट प्रेजेंट. तो आई विल एड अ डी हियर. दिस इज व्हाट हैपेंस हियर. So you can see this is what we are doing. For every character we are seeing that if that character is present, if it is not present, create a new node, add it, else move forward. And finally the cost of that node which we are inserting will be the minimum of the current cost. तो अगर वो नहीं पहले से प्रेजेंट ना तो करंट कॉस्ट इंट मैक्स हो जाएगी. बट इफ इट इज प्रेजेंट बिफोर देन यू विल टेक द मिनिमम कॉस्ट. जस्ट लाइक यहाँ पे आप देखो हमने 20 ले रहा है 70 हटा के, बिकॉज प्रीवियसली 70 was present. And now search is also similar, just like we do in a simple try. Search is exactly same, no difference, right? search means that we have to search for a particular string. Let's say हमें search करना है DEF. So we will say as a DEF present, okay, we will say D is there, okay, then E is there, okay, F is there, and then we will get the cost of it. This is how the search works, right? Now finally, how we can do it. So okay, I think this if function I didn't remove. This function is not required, the recursive function. This is the main function that we require, right? So first thing is that we will initialize our try. तो मैं इसको सबमिट कर लेता हूँ because ये better है, उसकी ज़रूरत नहीं थी, मैंने लिखा हुआ था, right. So as I said कि we will first of all initialize the try. Initialize try means that we will insert all our words inside that try. जितने words थे ये हमारे with their cost I will insert inside the try. You can see. Okay. Now what I will do, I will create a DP array. Now in the case when we will having TLE, we will taking a recursive recursive function there. Now we will do it iterative, and an iterative way will also be very similar. तो हम क्या करेंगे, that our DP of I will represent minimum cost to make string till index number I. Till I तक कितना minimum cost लगेगा. Let's say it is A B C D E F. तुमने कहा भाई पहले हमारा I यहाँ पर है at index number 0. आप देखो तो सिर्फ A तो present ही नहीं है, only A is not present. तो इसके लिए तो cost हमारी int max ही हो जाएगी. फिर A B is also not present anywhere, तो उसके लिए infinity हो जाएगी. Now for A B C it will search in the try and it will say that okay, cost is 100. This is how this whole will work. Now for D it will say what it is. So for D it will say okay, it is 10. Now for E there is nothing, but for DE there is something which is okay. For DE also there is nothing. Then for DEF there is something which is 20, and for EF it's 50. Oh sorry, हमें लगता है हमें यहाँ पे sorry. Actually I updated this EF here. This EF should be updated here, not here. It was DEF. Just a silly mistake I did. Yeah. So what I'm doing, that I'm taking my loop from 0 to the end of the string. If DP of I is currently int max, so initially to -1 होगा, initially to int max होगा. तो अगर DP of I int max है, means there is no way to reach that ith index. We will continue. But let's say we are currently at index number I. Now starting from I, moving forward we will see कि whether there is a string present or not. So यहाँ पे हम लोग same चीज़ ही कर रहे हैं. The only difference is in the previous case to check that whether that particular string present or not, we use a map. हम ये map use कर रहे थे previous case में. In this case we are using try. That's it. कोई भी और change नहीं है. The only thing is in the previous case we used to use map. Here we are using try. Same है. For example हमारा ऐसे है A B C D E F. Okay. So if you will see what it is doing, it will first start from I is equal to 1 and starting from I till end we will search for every substring. So first we will search for A. क्या A present है? A नहीं present है. Okay. Then it will search for B. तो देखो अगर present नहीं है then it is simply breaking. Now it will say A B present है? Yes, A B भी नहीं present है. अब देखो A B भी नहीं present है हमारे इस वाले केस में. अब क्या A B C present है? Yes, A B C is present. And when something will be present, its node value will be stored. This it will be present in this node. इस node में present है. ठीक है. अब अगर वो present है तो what will be the cost? तो cost हो जाएगी cost of DP of I में पता है कि I तक यहाँ तक cost कितनी है. अब उसके बाद हमने इतना part और लिया तो this much cost will be added and the minimum of that will be taken. So this is how we will move forward. For example कि भाई हमने ABC की कॉस्ट अभी तक कॉस्ट 0 थी, ABC की कॉस्ट लेट से 100 है, टोटल कॉस्ट होगी 0 + 100. ना जब हम आगे बढ़ेंगे सो वी आर डन विथ ABC, नाउ वी विल मूव टू DEF. तो व्हेन वी मूव फॉरवर्ड इट विल नॉट जस्ट चेक फॉर D, इट विल चेक फॉर ऑल ऑफ दैट. तो फर्स्ट इट विल चेक फॉर D कि D के लिए कितना आ रहा है. तो D के लिए कॉस्ट आएगी आई गेस कुछ 20 या फिर 10, तो 10 विल बी एडेड एंड देन फॉर रिमेनिंग सेपरेट कॉस्ट विल कंटिन्यू. And one case will also be जहाँ पर पूरा DEF ले लेंगे because we are starting from I till end only. तो only change is जो हमने पहले आपको explain किया था, this logic which I explained you previously. कहाँ गया? दिस लॉजिक कि इतना लिया फिर प्लस किया. द ओनली यहाँ पे चेंज इज कि इंस्टेड ऑफ मैप टू स्टोर द कॉस्ट वी आर यूजिंग अ ट्राई टू स्टोर द कॉस्ट. दिस इज द फर्स्ट चेंज वी आर डूइंग हियर. एंड इंस्टेड ऑफ मैप वी आर यूजिंग अ ट्राई टू स्टोर द कॉस्ट. ठीक है. एंड सेकेंड चेंज इज दैट दिस टाइम आई हैव रिटन अ iterative कोड इंस्टेड ऑफ द रिकर्सिव कोड. ठीक है. एंड फाइनली अगर आपकी जो पूरी लेंथ है, पूरा स्ट्रिंग लेंथ है, उसके लिए कॉस्ट इंट मैक्स है, मीन्स इट्स नॉट पॉसिबल, रिटर्न -1, एल्स रिटर्न वॉट एवर द कॉस्ट इज. ठीक है. So I hope that you have got the understanding of this. Please learn try if you don't know and you have any idea, because that is the important part here for this particular question. Thank you for watching this particular video. See you in the next video. Okay, sorry. Before moving forward, the time complexity we will see. So we have taken a space of try. Time complexity to search in try is actually the order of size of the maximum string. So I will probably say that the time complexity of this is means order of n for it, and this will also take, so it will be order of n square probably, but smaller than it, not the whole n square. uh, okay, yeah, it will be actually n square, it will be order of n square, and space complexity is order of n, right? This is the case. Cool guys, so I hope that you have got the understanding of this particular video. If you have any doubt regarding any question, you can ask that to me in the Telegram channel, or you can also ask that to me in the comment section. Thank you for watching this particular video. See you in the next video. Thank you.